Welcome to the latest edition of Changing Conversations with SGS as we discuss how we could move towards a better, safer, and more interconnected world. I'm PJ Kwong, and in today's SGS Live, we will delve into the realm of metal assessment with a focus on sustainability and precision. From non destructive to destructive testing, we'll uncover how these methods unveil the secrets of metal's composition, structure, and overall quality. Moreover, when it comes to investigating damage, we'll showcase our forensic approach and also talk about being dedicated to advancing circular practices and minimizing environmental impact. We're calling this session Innovative and Sustainable Methods for Assessing Metal Products. And as always, I'm joined by experts. And in today's session, no exception, I am delighted to welcome Martin Swinkels, the Senior Consultant Building Materials at SGS Intron. Welcome, Martin.
Hi PJ, excited to be here. Looking forward to tell you what my work is about. Looking forward to it.
Me too. So let's get started. Martin, can you tell me a little bit about what you do?
Well, I'm a consultant at SGS Entron, and like most of my colleagues, we work on building materials. We test them, do research into building materials, do damage investigations, maintenance issues, things like that. And if there are any problems which are to be expected, we look out what caused it, what we can do to fix them, who's to blame, things like that. That's our business here.
You know what? That is a whole lot. So I touched on this word in the introduction, and that is forensic. So, what is the difference between a normal approach and a forensic approach when metal damage is detected or is the case?
Well, the normal approach often is that some experienced inspector looks at this problem, sees something he has seen before, and maybe does some laboratory research, and then he says, "Right, this is it. Let's do this." Normally, that's good. That's fast. Often you need fast decisions and fast maintenance. But there are many other locations where you need more certainty, and in these kinds of things where you have to look deeper into these problems and not only your first judgments, but you have to look deeper into them, and you have to be sure that your first judgment is the right one or not, of course. And that's the real difference between your normal approach and your forensic approach.
So, I guess I want to know why. Why is it necessary to use a forensic approach for damaged metals? And is forensic assessment only feasible for metal experts?
Well, when do you need these kind of things? That's, for instance, when justice is involved, when there are liability issues, when there are real safety issues, then you need to be really sure what to do. And you cannot, a quick judgment is not enough. Then this is necessary. And of course, in these situations, there are many parties involved, and it could be hard to get all the information you want because everyone has their own story. And these are the moments you really need this. And this is not something you only use at metals, but really all problems, all building problems, but all kinds of other problems. You could use this same technique. And of course, we here do it with often metal problems because our laboratory is specialized in these metal problems, corrosion, things like that. We are specialized in that. Of course, we look at that part.
You know what? I'm not going to lie. This seems a little complicated for someone like me. So, how about you tell me what makes forensic assessment so difficult?
Well, the difficulty is, of course, that um, it's a difficult puzzle. The puzzle is my job. I make these puzzles, and I love making puzzles. And in this puzzle, I need many people who have different specializations. For instance, our laboratory. And what could be the problem is that You should look at it independent. Everyone in this situation has a bias, and everyone
Okay.
would like to see their point of view because maybe they are part of the cause of the problem, the cause of the problem itself, and they're a bit guilty. So we need to ask many questions and check over and over again, and be quite distrustful to be sure that you get the right answers or all answers are the same. And of course, you don't do things like that alone. You need a structural engineer, you need a laboratory, you need all these kind of things. And that's why I come in because I was trained as a structural engineer, but didn't like the calculations, but I know what happens there. I then specialized in building material science, things like that. I know what happens in the laboratory because we have a laboratory like that. So I can bring these things together with all kinds of other specialists.
It's fascinating when I listen to you about your training. I mean, that's one part that's almost theoretical, let's say.
Yes. Yeah.
So, do you have any example cases when you've used forensic damage assessment? And can you tell me more about what the approach was and maybe even the results as well?
Well, some time ago we were involved in the investigation into a football stadium where the roof collapsed. It collapsed on a windy day. People were lucky. It was a weekday. There was no match, so there were no injuries. But if there was a match, that I think would have been deaths there. So they were very lucky. It collapsed, and of course the question was, why did this roof collapse? Well, what we did, we did an inspection on site, and on site, of course, we saw the roof, half of the roof came down. Well, it was laying on the chairs of the stadium floor, and we also saw in the good parts of the roof that there were some, well, let's say brown lines where there were probably old cracks. We weren't sure yet, but we saw them. And well, it was the start of our investigation. We took the parts which were broken to our laboratory in Sittard. Well, that's always the first question. Where did it start? What was the first beam weld to break? Where did it start? And well, we were quite sure it was one of 4 or 5 places where it happened. We took those parts to our laboratory in Sittard, found out that the welds were, well, too small or hardly there. That there was some corrosion on the welds, that some welds had already been broken, well, sometime before, long before. So it was quite clear what was one of the causes of the problem. But there's never one cause in things like that. There are always 3, 4, 5 causes which work together to create a real problem. And when we looked into it further, another problem was that there had been no maintenance. No one looked at the corrosion of this roof. What you should do with a steel roof, you should inspect it once in 5 years or something to look if there are any problems, and then if you see problem, it warrants. And if they had done that, they could have seen that there were cracks already in place, and someone should have warned. Well, and when we looked into it deeper, there was no or hardly any quality control while building the stadium. So these things together cause these problems.
So it sounds to me in a way like information is power. So, you talk about maintenance, and in some ways, was it kind of lucky that this happened? Does this mean that there will then be information for other buildings of the same age? Because obviously, techniques and everything have evolved.
Yes, of course. Since then, there are some protocols in Holland to check these stadiums once every, I'm not sure, 5 years, I think, and to look at all these stadiums with this problem in mind and to look if they have the same problem. But often they don't have the same problem, but the same process are going on there. no maintenance or bad maintenance or no inspection. And now there's a law that you should inspect them, and there's a protocol which way you should inspect them. And often we help the owners with these inspections.
Amazing. You know what? It's going to be time right now to get our audience involved. And I've got a bit of a trivia question or a poll question, let's say, to bring into the mix. So here is the question for our audience. Do you recycle your beverage cans and electrical devices? And if so, A, yes, always. B, most of the time. C, hardly. Or D, I hope there's no D's, never. So it's about recycling beverage cans and electrical devices. A, always. B, most of the time. C, hardly ever. C, hardly. Yep. And D, never. Okay, while we're waiting for our responses to come in, Martin, tell me why any of this stuff is important. I mean, why are we recycling beverage cans and electrical devices? What is the impact? What is the importance?
Well, of course, this question is here because our next part is about sustainability. And I think
Okay.
we can talk about sustainability in our job, in our work. But most important is what you do yourself. Can you do at home? At work, well, you don't have that much influence. At home, you have influence, and you can uh, be sustainable. You can recycle your products. You can try to change the world, and we have to change the world because our raw materials are scarce, and we have to, well, use not too much on no raw materials if possible, but at least possible. And that's why this is important. We all have to do
Yeah.
this.
You know what's really interesting? Our audience, it looks like that the majority of our audience who are responding to this poll question are saying A, which is always. We've got quite a few Bs most of the time. Some people are saying C, hardly, as far as recycling beverage cans and electrical devices. And we even have a few Ds, never. So hopefully the world is going to get to a place where this becomes just an automatic. It's automatic as brushing your teeth. So it's very
Yeah.
interesting for me to see what the audience thinks, and this question is very important. And you know what? I have so many more. So let's keep going. And sustainability, as you mentioned, is getting more and more important, especially in the building industry, which has quite the carbon footprint. So, what can the building industry do with metals to reduce their carbon footprint? And are metals in general sustainable, or is it just steel?
What can we do? Well, of course, we could use no raw materials, but that's very hard, even well, especially in the near future. But until then, we have to use not too many raw materials. And the best thing to do that is to recycle or reuse these raw materials. And just construction steel is a material which is easy to be reused. It's uh, it's reused a lot. You don't have to put really much energy in it when you're using large parts. You don't have to put that much energy in it, and we can really use these parts easily. But it's also the same story for other kind of materials, but I think it's a bit more difficult because let's say aluminum, which is a material which can always also be reused, but there is not like construction steel. There is, well, let's say one major group of steel what's really much used, and all other kinds of steel are put into this big basket of steel when reusing. And for other kinds of materials like aluminum, you should use the same small part of aluminum with the same composition and try to reuse that. And that's more important, more difficult than reusing the structural steel. But same as all of for let's say non-corroding steels. Non-corroding steels have special elements, special metal elements in them, and you can only really reuse them well at a high price they have, and when you're really using making the same material with it. And that's more important, more difficult for those kind of materials and easier for construction steel.
You mentioned aluminum, and that's what we were talking about with those beverage cans. So every little bit helps. It's
Yeah. And with
and
beverage
for
cans, we
audience,
know what it is. It's always the same aluminum, so it's easy to
exactly.
reuse.
So, for our audience, if you're just joining us, we are speaking to my expert SGS from SGS, Martin Swinkles, about innovative and sustainable methods for assessing metal products. This is a fascinating conversation. There will be a Q&A at the end of this interview session. If you want in on that, leave your questions in the chat window below. And while we're at it, I want to take a look at some of the comments to see where our audience is coming from because we have the best audiences for these SGS changing conversations. So let's take a quick look to see who's joined us today. Serbia's in the house. Let's see who else. I saw Congo earlier, Ivory Coast, Argentina, and pretty much all four corners of the globe, Pakistan. Everybody is represented here. We want to say a big welcome to one and all. We are so glad that you've joined us today. So, Martin, we're going to continue with our conversation. I've heard about a 10R model regarding circularity. How does steel fit into this?
Well, the 10 arm model ranges from not using any raw materials to, well, landfilling them, just dumping them away. And of course, reusing and recycling is in the middle. We try to reuse large pieces of steel or other materials, and or we try to recycle them, but then we use the scrap to make new metals, which of course costs a lot more in the, energy to do this. So it's not the best option, but if you cannot do better, it's an option. It's better than throwing it into a landfill, of course.
We've talked a lot already sort of about recycling or reusing. And I guess I want to know which one is better as far as, recycling or reusing steel according to carbon emissions.
Okay, we want to reuse things. Reusing them is
Okay.
much more interesting than recycling them because reusing them means we don't have to put new energy into these steel things to reuse them. If we um, put them into the scrap and make new steel of it, we have to melt it down and to mold it again. So that's not really the thing you'd like to do, this recycle part. And reusing, you can look at two different ways of reusing them. You can reuse an entire building. Now, of course, if it's a steel building, you could reuse the entire building. And of course, then you only have to change the foundation to reuse this building. Or you could use the large steel beams in the building, which are, well, quite the same. The quality doesn't go bad in normal situations when there's no corrosion and there are no deformations of the steel. You can reuse and reuse and reuse these large metal parts again and again and again. And of course, that's the most uh, interesting thing to do.
So, kind of along those same lines, I guess I'd like to know more about the protocol for the reuse of structural steel and your contribution, and then what's most important when it comes to reusing steel elements.
Yes. In Holland, we made a protocol to reuse large steel elements to promote this thing. And well, one of the problems was that when steel is reused, um, no one is sure about the quality. And there's always a discussion about the quality. And the people who sell it say it's great. People who buy it say, well, maybe were some problems. And according to what codes can I do the calculations with this old steam, new codes or old codes, there's always kind of discussion like this. And in this protocol, we like to agree on the normal way of working and the normal way of doing these things so that you don't need these discussions anymore. But of course, if you want to use it in a large area, there are some boundaries which you have to stay into. Well, in this protocol, the most important thing is to know where this steel came from. to know enough from the old building where this steel was harvested. Harvested is a new word. Well, it's not a new word, but in the building industry, it's a new word. Some time ago, someone who demolished a house now is a harvester, which of course sounds a lot better. But it's very important to know what was the quality of this steel when it was first put in. And if this information is good, is really good, you don't have to test that much to reuse it. But if you don't know where it came from, you don't know what the quality was, you need to test a lot more to find out what it is. And more especially, if you know enough about the building, you can say, well, these 10 columns are used exactly the same, and those 10 beams are used exactly the same. We only have to test one of them. So if you know more about these buildings, so you need the original drawings and as accurate as possible, because you could have design drawings where you're never sure if they are really used, or the real building drawings or the as-built drawings, which are every time more precise. So we need the most, the best, and the most, the last information on these buildings. And of course, if you want to reuse these steel elements again in 15 years, you still have to know where they came from and where they came from before that. So it's very important for when we want to recycle these large building materials that we know their history and that we uh, make a record of their history. And well, it's a big question for the industry how to do that. Do we need some big? Can we put a chip into them where all the information is stored, or do we need new piles of drawings with information? And as we all know, these piles of drawings are lost in 10 years. No one knows where they are. Are they digitalized? But in another system, things like that. It's very difficult to, to gain this information.
Okay, so there are a lot of steps in that are necessary in order to reuse steel elements. So just between you, me, and maybe the hundreds of people who are watching, is it worth it when it comes down to sustainability? Just between us.
Yes, it's worth it. Well, we should do it. There's no question. We should do
Okay.
this. But it's worth it. Still, the price of used steel elements is lower than new steel. Well, that's one reason you could do it. And often these days, new steel is hard to get, and the old steel is easier to get. Those are also reasons to do this. But main reason, if to want to reach our sustainability goals, we have to reuse things.
Fair enough. You know what? This is a fascinating conversation. And if you're just joining us, we're talking about assessing metal products and the next steps with my guest, SGS expert, Martin Swinkels. We've got one more question to go before our Q&A. And if you want to leave us a question or a comment, please do so in the chat window below. Lots of great questions coming in. Keep them coming. We're going to try and get to as many as we possibly can. Okay, Martin, here is my final question. I need you to look into your crystal ball. Do you have it handy? It's about the future. I want to know if what is the future, or will there be a future in reusing steel? Will it be possible to reuse steel products or even other metals? What do you think?
The future is now. I don't think there is hardly any steel which is landfilled, which is not reused at in some way. A bit is recycled, a lot is reused as large beams. Maybe not in the same quality as it was used before, because no, when we try to reuse something, we try to reuse it in the highest quality, the old quality or better. Um, but I think most of nearly all steel is reused at this moment or everywhere in the world. So, well, that's quite good. But I hope that we'll reuse it in a higher, in a better quality each time. So, and to do that, we need to store this information on these parts. And that's the important thing. And well, I hope that sometime in the near future, there will be a chip or there will be a system with a QR code on each building material where you can find out what the quality is, where it made, what the quality was, etc., etc. That would be my vision of the future.
You know what? It sounds very optimistic. I mean, I love that. I love that. You know what? We're going to get into our Q&A, and I know that you're good with some questions. We're going to try to get to as many as possible from our audience. So let's start with this first one. We talked about reusing steel, and it would be handy to understand the parameters around that. I mean, can you use what can you use and where? In other words, I'm pretty sure you can't use that broken roof that fell down on that stadium, but are there any other sort of guidelines?
Now, let's say normal buildings where the steel is not corroded, or not too much corroded, where it's not cut, where it's not really bended because of well, something, some accident, things like that, or an earthquake, things like that. All kind of other steel, well, and steel which have had an what? Oh, I can't. I'm not sure what the word is. Dynamic, which had a dynamic load. You cannot
Okay.
reuse because it's very hard to see what pain, what's caused, what changed in the steel. But all other materials in these buildings could be reused. And in Holland, it's mostly material buildings which were built after 1955, because from
Yep.
then all the codes were present, were there, and we can easily find what the quality was. Before that, it's a bit harder because there were no codes, and everything was different. There were no standard materials. But from 1955, and most countries have some year like that, where they started with the building codes and started using standard steel parts, and then it's easy to reuse them.
You know what? We've got a great question from our audience, and that is how can alloys be recycled?
Well, the recycling of alloys is very hard, and up to now the only feasible solution is getting the same kinds of alloys together and reusing it, because you really have to know what kind of materials there are, what kind of alloys there are, because all these different materials into these alloys. If you really know what it is, you can make the same alloys or you can make a new mix, but then you know what's in it and then you can reuse it. So for alloys, it's even more important to know what you are using. And in construction steel, if there are some alloyed pieces of alloyed steel, it's not really a problem, but it's a waste of good material to put these alloys into our construction steel. So most can be reused, but it's very hard to get them in recognizable groups together to know what you have.
Boy, that's fascinating. There is so much information to cover here. We've got another great audience question. Shouldn't we start using reinforced polymers in place of metals?
Well, I'm not an expert at the comparison of these materials. My colleague Agnes is, but so if I look at it from my point of view, reinforced polymers are very hard to recycle. I don't think there are really any procedures to recycle these things at the same quality, of course. And I know that the durability, not sustainability, but the durability of the reinforced polymers is also not really good. And it's very hard to repair them. Now our steel, our concrete, these things, we know how to repair them. And we can keep these buildings alive for very long period of time. But when we have reinforced polymers instead of metals, we don't know yet how really to repair them on a large scale. So I'm not sure if this would be the best solution, but that is not my job.
Do you know what, Martin? For someone who says they're not an expert, it sounds like a pretty expert answer. But anyway, thank you for that great question and that very interesting answer. There's so much to consider. So, this is now my final question. And I guess if someone in our audience needed help in some way, what do they need to do first? I mean, what kind of clients are you working with who can benefit from the assessment of metal products?
Well, of course, when you have a building somewhere in Pakistan, don't call us. It's SGS Intron in the Netherlands. That's too far. But I'm sure you can use our Dutch procedure to use in your own country, and we would be glad to help you with translating that to another situation, another country, another situation. We could help you very good in doing that. And we can also help you if you have really difficult metal problems with corrosion, with damages on metals, and when it's a real difficult situation with an interesting puzzle, I would be glad to help you.
Do you know what? That's wonderful. And for those of you who left a question in our chat, we will get to them. Don't worry, but it'll be offline. So just have faith. We're coming for you. Don't worry. Do you know what? I've got to tell you, Martin, this has been a fascinating conversation. And thank you so much for joining me. This has been Martin Swinkles, the Senior Consultant Building Materials at SGS Intron. You are a treat in all of this. Thank you so much. And
Thank
we've
you
been
very much.
talking about Oh, you're welcome. We've been talking about innovative and sustainable methods for assessing metals. If you have any questions or require any additional information, you can always reach out by leaving your information in the Q&A in the window below, and we will get in touch with you, that's for sure. Thank you so much for watching. I'm PJ Kwong. Bye for now.